All right, so when you hear quantum mechanics, what comes to mind? Probably dusty chalkboards, maybe some century-old equations, right? But what we're going to talk about today is why this isn't just history. It's actually the blueprint for our entire future. So let's pull back the curtain on what's really happening in this strange and incredibly powerful new era. And look, that isn't just some hopeful statement. We are literally living through what everyone is calling the second quantum revolution. So the first revolution, that gave us the theory. This new one, though, is all about putting that theory to work, about bending the bizarre rules of the quantum world to our will, and creating some truly incredible new technologies.
So what kind of technologies are we talking about here? Well, for starters, how about a global internet that's completely unhackable? I mean, how is that even possible? It's because at the quantum level, the very act of looking at something changes it. So if some eavesdropper tries to intercept a message, the laws of physics themselves will literally alert you. Your data wouldn't just be encrypted, it would be physically unspyable.
And it goes way beyond just secure communication. This whole revolution is charging ahead on 3 different fronts. You've got quantum computing, which promises to solve problems in medicine and material science that are just flat out impossible for even the fastest supercomputers we have today. Then there's quantum sensing, creating devices so ridiculously precise it can map your brain activity in unbelievable detail. And of course, as we just saw, quantum communication, which is set to completely redefine what it means for something to be secure.
I know. This all sounds a lot like science fiction, doesn't it? So how does any of it actually work? Well, to get a handle on the technology, we first have to wrap our heads around a few of the bizarre, totally counterintuitive rules that run the quantum realm. And trust me, this is where things get really weird.
Okay, so think about a regular computer bit. It's like a light switch, right? It's either on or off, a 1 or a 0. Simple. But a quantum bit, or a qubit, can be both 0 and 1 at the exact same time. That's superposition. This means it can explore tons of possibilities all at once, and that is the secret sauce behind a quantum computer's insane power. It only picks one state, a 0 or a 1, the moment we actually measure it.
You've probably heard of the most famous example of this, Schrödinger's cat. It's a thought experiment, of course, but you imagine a cat in a sealed box, and its fate is tied to a totally random quantum event. Now, according to the rules of superposition, until we open that box and take a look, the cat is in this bizarre blended state of being both alive and dead at the same time. Yeah.
Next up, we have something so strange that even Einstein couldn't wrap his head around it. He called it spooky action at a distance. It's called entanglement. Imagine you have 2 coins that are magically linked. If you flip one and it lands on heads, you instantly know the other one, even if it's on the other side of the galaxy, has landed on tails. That's what entangled particles do. Their fates are connected, instantly, no matter the distance.
And finally, there's this mind-bender, wave-particle duality. You know, in our world, things are either particles, like little bullets, or they're waves, like ripples in a pond. But down at the quantum level, that whole distinction just vanishes. An electron can act like a solid little particle, sure, but it can also act like a wave, creating interference patterns as if it went through 2 different places at the exact same time.
Now, what's so amazing is that these revolutionary ideas aren't really new. This timeline is basically a who's who of 20th century physics. For decades, absolute geniuses like Planck, Einstein, Bohr, and Heisenberg were all wrestling with a version of reality that just completely defied common sense. And in doing so, they rewrote the fundamental rules of physics.
And for them, this wasn't just abstract math on a page. It was a seriously profound discovery about how reality itself is put together. I love this quote from Werner Heisenberg because it just captures that sense of absolute awe. He felt like he was peeling back the surface of the world and seeing this hidden, beautiful structure underneath it all.
Okay, so this brings up a really good question, right? If the theory has been around for a century, why is this second quantum revolution only happening now? Why don't we all have quantum computers on our desks? Well, the answer comes down to just how incredibly difficult it is to control the quantum world.
This quote from physicist Barbara Turhall really gets to the heart of the problem. You see, quantum states are unbelievably delicate. The tiniest vibration, the smallest change in temperature, what scientists just call noise, can completely destroy that superposition and cause the whole calculation to fail. That's why building something called quantum error correction is one of the single biggest engineering challenges on the planet right now.
And the effort to solve these challenges is massive. I mean, just look at this number, over 60. That's how many global conferences and industry events just one single quantum tech company attended in 1 year. This is not some quiet academic thing anymore. It's a full-blown global race between governments, startups, and all the tech giants.
But, it's not just about building better hardware. The biggest challenge of all might actually be building a skilled workforce. To make this revolution happen, we need an entire ecosystem of people who are quantum conversant. And that doesn't just mean training the next generation of physicists. It also means the technicians, the engineers, and even the executives who are going to build and lead this whole new industry.
So all this new progress is finally letting us ask some of the biggest questions you can possibly imagine. For example, is gravity quantum? Right now we have two rulebooks for the universe: Einstein's theory of gravity for big stuff and quantum mechanics for tiny stuff. The problem? They totally contradict each other. For the first time ever, we might finally have tools sensitive enough to find out if gravity itself has to play by quantum rules.
And here's another wild frontier. Does all this quantum weirdness actually play a functional role in living things? This is a whole new field called quantum biology, and researchers are seriously looking into whether quantum effects could explain mysteries like how a bird can navigate using the Earth's magnetic field, or even how photosynthesis is so incredibly efficient.
And finally, here's a question that kind of brings us right back to where we started. We know these quantum rules apply to tiny little things like atoms and electrons, but can we push them further? Can we actually create large macroscopic objects, things we can actually see, that exist in a state of superposition, just like Schrödinger's cat? The answer is still a big we don't know, but we're getting closer to finding out.
And really, this is the perfect thought to end on. 100 years ago, a lot of physicists genuinely felt like they had pretty much solved everything. Quantum mechanics blew that idea out of the water. Today, we might feel like we're close to a complete picture again. But this second quantum revolution might just be showing us that we are, once again, only at the very beginning. So what new, beautiful interior are we going to discover next?